Today I'm going to quickly go through a unit on rational functions. The first blank says a blank can be written in the form n of x over d of x, where n and d are polynomials and d is not the zero polynomial. That's a rational function. And that's just two polynomials divided by each other. Includes all real numbers except the x values that make the denominator equal to 0 is our domain. And we've had some practice finding the domain already. The line x equals a of a graph if I approach infinity or negative infinity from the right or from the left. What that's really saying is the value I approach as I approach from the left-hand side or the right-hand side, I'll get closer and closer and closer to it, but never actually hit it. That is from a vertical asymptote. The line y equals b of a graph as I approach infinity or negative infinity. Well, that's the same idea, except instead of being a vertical asymptote, it's a horizontal asymptote. So as I go left and right again, I will be approaching a horizontal line. When I approach a horizontal line, it's called a horizontal asymptote. The first example we're going to use our calculator for. Unfortunately, I can't show my calculator on this particular video. However, you can type this equation in your calculator for me. In y equals, please type 1 over x. I'll give you a second to do that. If you're having any problems viewing it, just make sure you hit zoom standard and you should have a standard window. Okay, I'm going to go ahead and draw a sketch because I can't show you my graphing calculator at this point in time. But a sketch of y equals 1 over x would look something like this. And I shouldn't have touched that x-axis. It's hard for me to sketch on this particular video. Based on that picture, I want to find the domain, the horizontal, and the vertical asymptotes. Well, my domain, again, are all the x values which are defined except where the denominator would equal 0. In this case, if I look at my denominator is x. So to figure out the domain, what I am going to do is you set your denominator equal to 0. If there's anything to solve, you would, but this is already as an x equals form. So my domain is going to be everything but that. So for domain, I'm going to say it's all real numbers. However, x cannot equal 0. For my horizontal asymptote, I'm just going to abbreviate HA. If I look at my graph, horizontal asymptote would be, this line right here. It would be the horizontal line that my graph should be getting closer and closer and closer to, but never actually touch. That horizontal line should be right on your x-axis, and that's the equation y equals 0. Now for my vertical asymptote, it's the same idea. I look for an area where I could draw a vertical line, which would be this line right here, where my graph gets closer and closer to, but will never actually hit. Well, that's right on the y-axis, and the equation of that line is x equals 0. So hopefully looking at a graph, you can see what the domain, horizontal, and vertical asymptotes are. However, I'd like to do it without having to look at the graph all the time. I want to do it algebraically. And that's what the next piece says. What if we don't want to look at the graph to determine the domain and the asymptotes? How do we look at it algebraically? Well, this is how we will find some asymptotes, and we will continue to do the domain the same way we were doing before. So it says let f be a rational function given by n of x over d of x. So we just have a division of two polynomials. Also, they cannot have common factors. The graph will have a vertical asymptote where the denominator equals 0. That's what the 0 is at d of x. So the way we find a vertical asymptote is you set your denominator equal to 0 and solve. The number 2 says the graph will have one or no horizontal asymptotes determined by comparing the degrees of the numerator and the denominator. For example, A, if the degree of the numerator is less than the degree of the denominator, such as something like 2x over 3x squared. The highest power in the numerator is a 1, which is less than the degree of the denominator, which is squared. Since that is the case, the graph will have the line y equals 0 as a horizontal asymptote. If the degrees are equal, such as for B, 2x squared over 3x squared. So you can see the highest powers are squared. They're equal in numerator and denominator. Then it will have the line, and I'm going to write this and then explain it. Y equals A sub n divided by B sub m, which means the ratio of the leading coefficients. In the case we have on the left-hand side here, you see that the numbers in front of your x squareds are 2 and 3. So that means that your equation for the horizontal asymptote would be y equals 2 divided by 3, which is 2/3. And we'll practice this below, so don't worry if you're a little confused right now. And finally, part C, if the degree of the numerator is greater than the degree of the denominator, so something like 2x squared over 3x. Highest power in the numerator is greater than the power in the denominator. In this case, the function has no horizontal asymptote. It would just be none. Now let's try to use our rules to find the domain, horizontal, and vertical asymptotes of each rational function. The way we'll find the domain is the same as before. We set the denominator equal to 0 and solve. For the vertical asymptote, it's the same idea. We just have to make sure that we don't have any common factors in the numerator and denominator. For horizontal asymptotes, we'll use the number 2, A, B, and C to determine it. So looking at our first problem we have here. First of all, I see I can't factor the numerator. If I were to factor the denominator, it would factor to x plus 1, x minus 1. But there's no point in doing it because I wouldn't be able to cross off anything with the numerator and the denominator. So my first step for the domain, what I'm going to do, excuse me, set the denominator equal to 0 and solve. So I'll add the 1, take the square root. Based on that, I'm going to say my domain is going to be all real numbers. However, x is not allowed to equal plus or minus 1. For my vertical asymptote, what it says to do is you set your denominator equal to 0 and solve. Well, we already did that for the domain. So my vertical asymptote is x equals 1 and x equals negative 1. And finally, for horizontal asymptote, we had to compare the degrees of the numerator and the denominator. I see the highest power in the numerator is squared. Highest power in the denominator is squared. Since they are equal, it's 2b. When they're equal, what you do is you divide the leading coefficients. So in this case, the leading coefficient is 2 and a 1. So my horizontal asymptote will be y equals 2 over 1, which is just a 2. Moving on to the problem on the right-hand side. We have x squared plus x minus 2 over x squared minus x minus 6. To find our domain, we set the denominator equal to 0 and solve. Oops. This will factor. It factors to x minus 3, x plus 2. So we get values of 3 and negative 2. Therefore, our domain is all real numbers. However, x is not allowed. Sorry, my cat is rubbing against me at the same time as I'm trying to write. Negative 2 and 3. For my horizontal asymptote, my vertical asymptotes, what I have to be careful of is that there are no common factors. Okay, right now I have to factor this and cross off anything common that I have at this point. X squared plus x minus 2 factors to x plus 2, x minus 1. Denominator factors to x minus 3, x plus 2. I see I have x plus 2's common. So I cross them out, and I'm really left with x minus 1, x minus 3. So when I get to my vertical, asymptotes, I'm just going to be looking at the x minus 1, x minus 3. So vertical asymptote. Oops. If I look at the directions again, it says set your denominator equal to 0 and solve. So I'll get x equals 3. X equals 3 is my only vertical asymptote. Now for the horizontal asymptote, what I do is I compare the degrees of the numerator and the denominator. And again, I look at my new version. Since my new version, the highest power is the first and the both of them, what I do is 2b, which you divide the coefficients. The leading coefficients are 1, so my horizontal asymptote is y equals 1 over 1. Which is just a 1. I'll try to go a little quicker through these next two. I can see on this next one that I have, I can find the domain. And the domain is going to be the same as it was in the problem that you have above or on your previous page, because it's the same denominator. So my domain is all real numbers, however, x is not allowed to equal plus or minus 1. I can also see that my vertical asymptote is going to be the same as well as it was on the problem that you have at the previous page. Because I have nothing to cross off, my vertical asymptotes are just x equals 1 and x equals negative 1. Horizontal asymptote is where it's different. Notice the degree in your numerator is greater than the degree of your denominator. Highest power in numerator is cubed, highest power in denominator is squared. When that is the case, that is number 2C. There is no horizontal asymptote. So I'm going to write none. And finally, this one over here. For my domain, I set the denominator equal to 0 and solve. So I'll add the 16. Sorry, cat wants to go out. Give me 1 sec. You get x squared equals 16. Take the square root of both sides, and you get x equals plus or minus 4. Now, for the asymptotes, before I can start those, I have to factor and cross off common factors. So in the denominator, I know that factors to x plus 4, x minus 4. X minus 4's cancel. and you're left with 1 over x plus 4. Now, based on that new fraction, to find my vertical asymptote, I set the denominator equal to 0 and solve. I can see my vertical asymptote is negative 4. For my horizontal asymptote, what I do is I compare the degrees of the numerator and the denominator. The degree in the numerator is less than the degree of the denominator. When that is the case, that's your choice 2A. You have the equation y equals 0 as your horizontal asymptote. So I'm sure you'll be trying a couple of those problems tonight, but we just did 4 of them together. The last piece I want to do is I want to graph a rational function without having to use our calculator. And I have the steps there for us. First step, we're going to simplify. Second step, we will plot the y-intercept by plugging a 0 in for x. Third step, we're going to find the zeros of the numerator, if possible, by letting the numerator equal to 0 and finding the x. That'll give us the x-intercepts. Step 4, we're going to find the zeros of the denominator and find asymptotes, vertical asymptotes. We'll look for horizontal asymptotes. We'll plot some couple extra points, and then we will complete the graph. So, let's go through the steps for this one problem. Step 1 says simplify if possible. Well, in this case, for step 1, there's no simplification, factoring, crossing off, anything like this. So we could really skip step 1. Nothing we have to do. Number 2 says find and plot the y-intercept by evaluating f of 0. Well, f of 0, what you're doing is you're plugging in a 0 for x. In this case, you get negative 3/2. Now, I did not give you a graph, so do the best you can. You should have a lot of room over on this right-hand side here. I'm going to go over here and draw my graph as well. You should be able to do better than I can do, but do the best you can. We need an x and a y axis. And I would say go out to 5 in every direction. Okay, the first point that once you have it set up, the first point you plot is for step 2, 0, negative 3/2. Well, 0, negative 3/2 is going to be right here between negative 1 and negative 2. Step 3, if I go back up for a second, says find the zeros of the numerator, if possible, and plot the x-intercepts. So what you would technically do for step 3 is you set your numerator, in my case it's a 3, equal to 0, and solve. In this case, there's nothing to solve there. So for this particular problem, there are no x-intercepts. Now I'm just going to write that just because it's our notes. For step 4, find the zeros of the denominator, and that's going to give us our vertical asymptotes. So x minus 2, set that equal to 0. Solve for x, and you get x equals 2. Now remember again, that's our vertical asymptote. So at x equals 2, you should have your vertical asymptote. Find and sketch, this is step 5 now. Find and sketch the horizontal asymptote by using the rules from that number 2 we had on the previous page. Well, looking at this, the degree in the numerator is less than the degree of the denominator. When that is the case, we say that y equals 0 is our horizontal asymptote. So at y equals 0, I'm going to draw my horizontal asymptote in. Number 6 says plot some extra points so we know what's happening here. I do know I need to follow my asymptotes. I do know I have to hit the points that I've plotted so far. Based on that, I know that I can graph the following sketch so far. So since I know I can't go past my asymptotes, but they're going to follow along with it, I have at least the bottom half of the graph. However, I don't really know what's happening at 2. Or after 2. I don't know if the rest of my graph's going to be down here or up here. So what I'm going to do is I'm going to find what f of 3 is. Maybe f of 4 if I feel like I need to. And that's going to tell me, should I graph it up here or graph it down here? And that's what step 6 is. So for step 6, I said I wanted to plug in a 3. So when I plug a 3 into the equation, it would be 3 over 3 minus 2, which is a 3 over 1, which is 3. So that tells me I need to plot the point 3, 3. Now if I wanted to, again, I could find f of 4, which would be 3 over 4 minus 2, 3 halves. So I'd plot the point 4, 3 halves. 4, 3 halves, that's going to be between 1 and 2, something like this. Based on those 2 points, I can see for sure, and the fact that I have to follow my asymptotes, that the second half of my graph would look something like that. If I wanted to, I could type 3 over x minus 2 on my calculator to verify that all of that information I have there is correct. But that kind of combines everything we've been doing for the last few days here. And we're going to practice this more tomorrow. I just wanted to introduce it today. At this point, you can work on the problems at the bottom. If you missed anything, you can go back and replay the video or get it from a friend.